So today in chapter 3, we'll study another important topic in numerical analysis, namely interpolation polynomials. So we'll see the definition and properties of these polynomials and their interest in practice. Just remember, we have already seen one important polynomial in chapter 1. Who can remember which polynomial did we study in chapter 1? Exactly, Amru. So we studied Taylor polynomials. Taylor polynomials, another important family of polynomials. So this is a new family. As we'll see, what is the main difference between Taylor polynomials and interpolation polynomials is that Taylor polynomials is constructed around a point in a neighborhood of a unique point x naught. And we use the derivatives of the function f to be approximated at x0. So the formula for Taylor polynomial Tn of x is the sum for k from 0 to n of the kth derivative of f at x0 over k factorial x minus x0 to the power k. So this is Taylor polynomial, and this polynomial approximate the value of our function f in a neighborhood of the single point x0. So here we focus on close to a point. We focus here, okay, on close, on small interval, okay, and we take a lot of information about the function f and its derivative at this point. Okay, this is for Taylor polynomial. Now f of x0 plus f prime x0 x minus x0 plus f double prime over 2 factorial. So here it's 1 factorial, it's 0 factorial, x minus x0 square, and so on. كل ما نزيد the information, كل ما we increase the degree of this polynomial, كل ما we improve the approximation of the function f close to the point x naught. This reminder of Taylor polynomials. What about interpolation polynomials, which is the topic of this lecture? So we'll introduce these polynomials, and we'll introduce several methods to determine these polynomials, different types: Lagrange, divided difference, and Hermite interpolation. Of course, there are other types of interpolation polynomials, but we'll stick to these 3 cases in this course. Okay, let's start. So the Lagrange interpolation polynomial, we need the function f, which is continuous and differentiable n+1 times in an interval AB. And in this case, the difference compared to Taylor, in Taylor we are given only 1 point x naught. Here we are given n+1 points x naught to xn with their images, the output f of x naught, f of x1, f of xn. So we know the value of the function at n+1 different points. So for Taylor, we have only 1 point, x0. But we know all the derivative of f and the value of f at this point, f double prime, and so on. This is for Taylor. We focus on a single point. Here, we have n plus 1 point, different points. So the problem is to find the polynomial again of degree n, since we have n plus 1 points, such that here, given the points, so this is x0, y0, x1, y1, x2, y2, x3, y3, so on. And we look for a polynomial of degree n passing through all these points. Okay, this is the polynomial Pn of x. Of course, the function f is a bit different. So the function f will have the same value as this polynomial. They share the same values at these points. So we have the information that we have. So this is the function f. So the information is that P and F coincide at these n plus 1 points x. Okay? And this polynomial will be an approximation of f. The quality of approximation, we'll see what is, how can we have information about the error, the difference between f and Pn in points, in other points except i's. And the idea is always to replace the function f by an easy function, which is a polynomial in our calculation, to calculate a derivative, to calculate an integral. So it's better to deal with polynomials instead of a function f. And even in some cases, we don't have access at the expression of the function f. We know f only in, we do measurements, we know f only on some given finite number of points. So this is the main idea and the main difference with the Taylor polynomial. So let's try to construct this polynomial. We start by the easiest case, which is the polynomial of degree 1. So a linear Lagrange interpolating polynomials. So linear degree 1, we need 2 points. So we are given 2 points here. x0, y0, x1, y1. Given 2 points, we are trying to find the polynomial, linear polynomial of the polynomial of degree 1. The polynomial of degree 1 passing through these 2 points. So such a polynomial can be written in such a form. Okay, so here f of x0 is y0 is the image of the first point, fx1 is y1, the image of the second point, and here we have this. So these are constant, and these are polynomials of degree 1. The first one called L0. So let's see how is L0 constructed. So it's x minus x1. So the difference between x and the other points, excluding x0, and in the denominator, we just replace x by x0. So here for L1, we make the difference with the other point x0 in the numerator, and we replace x by x1 in the denominator. Okay, doing so, we can calculate p of x0, for example. We'll see that if we replace here x by x0, we'll have x0 minus x1 over x0 minus x1 f of x0, plus we replace here x by x0, f of x1. So here this quantity equals 1. Same numerator, same denominator. So we get f of x0. And this quantity x0 minus x0 is 0. So this is 0. So we see that P and F match, the value of P and F match at the point x0. The same, if we calculate P of x1, we replace here in the expression, we have x1 minus x1 over x0 minus x1. So we have just to replace the value of the variable x by x1. fx0 plus x1 minus x0 over x1 minus x0 f of x1. So here we see that this quantity is 0. x1 minus x1 is 0. So هذا يروح وهنا x1 minus x0 over x1 minus x0. This is 1 and P of x1 equals f of x1. And here we see that we match our constraint is that P, the graph of P and the graph of F passes through these 2 points, x0, y0, and x1, y1. So the property of L0 is that L0 of x0 is 1 and L0 of the other points is 0. The same here, L1 of x0, if we have different indices, the value is 0. If we have the same index, the value is 1. You can check. This is the property of this Lagrange polynomials. Okay, so this is the idea. The idea is easy, and you have to know this formula. Okay, and these properties. So let's see an example, a simple case. Determine the linear Lagrange interpolation polynomial passing through these 2 points. The formula L1 here of x, L1 because we have 2 points. So degree 1 linear. So the formula is, if this is x0, y0, this is x1, y1, the formula is y0, not, okay, we call it P1. So P1 of x, which is P1 is the linear Lagrange interpolation polynomial. This will be y0, L0 plus y1, L1. This is given, this is 4, this is given, this is 1, this is y1, this is y0, and we have to calculate L0 and L1. So what's L0? L0 is x minus x1 over x0 minus x1, and we replace. So we get x minus x1. كم قيمة x1?
5
5 over x0 كم?
2
2 minus x1 is 5. This is L0 of x. So it's x minus 5 over negative 3. What is L1 of x now? It's x minus x0 over x1 minus x0. So it's x minus 2 over 5 minus 2. So it's x minus 2 over 3. And now we just replace here in this formula. We get 4 times x minus 5 over negative 3 plus 1 times x minus 2 over 3. This comes here, and this comes here, and then we can simplify. We can complete the calculations. So here, minus 4x plus 20 over 3 plus x minus 2 over 3. So we get same denominator, so we can add. over 3. So it's minus 3x plus 18 over 3. So it's minus 3x over 3 plus 18 over 3. So it's minus x plus 6. This is the linear Lagrange interpolation polynomial in this case. We can check if you want to be sure that we didn't do a mistake. So what is P1 of x0 which is P1 of 2 شو لازم تكون النتيجة حتى يكون حسابنا صح؟ المفروض كم P1 of 2؟
0.
لا P1 مش L1. قلنا لازم يمر من النقطة هذه. So P1 of 2 لازم يكون 4. هل هو 4؟ Let's check. We replace 6 minus by 2. Minus 2 plus 6 equal 4. And the answer is correct. P1 of x1 شو لازم يكون؟ اللي
5.
هو P1 of 5. شو لازم تكون النتيجة؟
1.
لازم تكون 1 لأنه يمر من النقطة هذه الثانية أيضا. And if we replace x by 1 here in this expression, minus 5 plus 6 equals 1. Yes, correct. So this polynomial interpolate these 2 points. Okay, which means that these 2 points are on the graph of this polynomial. Then هنا we have to calculate L0 and L1 here using the formula x minus x1 over x0 minus x1 و L1 هي x minus x0 على x1 minus x0. Okay, and then you replace this is L0, this is y0, this is L1, this is y1. Okay, this is the formula, and this is the final result. This is the linear here, degree 1, Lagrange interpolation polynomial. So interpolation means find a polynomial which graph passes through all the given points. Okay, this is the idea. So this is the general case. So here it's not any more linear, but here this is the general formula. Of the Lagrange interpolation polynomial. What is the formula? It's fx0 L0 plus f1 constant L1 of x plus f2 L2 of x plus till fn Ln of x. Okay? Because here we are given n plus 1 distinct numbers from x0 to xn. So we'll obtain a polynomial of degree n, but we have n plus 1 Lagrange polynomials to calculate. L0, L1, L2 till Ln. There are n plus 1 polynomials. Each one is of degree n. Okay, so this is the formula. It's the sum from k0 to n, f of xk, lk of x. Okay, what is the expression of each lk of each Lagrange polynomial? It's the product of x minus x0, x minus x1, x minus x2 of all these differences except for I equal k. Okay, what does it mean? It means that if you have, for example, 5 points, x0, y0, x1, y1, x2, y2, let's take 4 points. شو راح يكون L0 of x؟
x minus x1.
نبدأ x minus x1، ما نسوي x minus x0 times x minus x2 times x minus x3. وفي ال denominator same but we replace only x by x0. Okay, إذا عندنا x0 minus x0 0 في ال denominator it will not be defined. إذا نحب نحسب L2. شو راح يكون L2؟
x minus x3.
لا، نبدأ من أول. x minus x0 okay because 0 is not 2. X minus x1 because 1 is not 2. X minus x2 no. X minus x3. Then we multiply all this polynomial of degree 1 x minus xk except k equal to على في denominator راح يكون x2 minus x0 x2 minus x1 x2 minus x3. وضحت الفكرة ولا ما وضحت؟
You just switch it, right?
Here it's the product of all x minus xi هم all the given input except 1 اللي هو I equal k. هنا except 2. مثلا L1 شو راح تكون L1؟ عندنا 4 points يعني عندنا product of 3 such differences اللي هم x minus شو؟ يعني عندنا 1
x0
ناخذ الزيرو،
x0
هل ناخذ
بعدين
ال1
2 3.
2 و 3؟ ال1 ما ناخذ. اوكي، وين ناخذ x1؟ هنا replacing x in the denominator.
Yes.
I think it's easy to remember. Okay, you take all the products x minus xi except 1 اللي هو هنا x minus x1 اللي هو هنا ما تاخذ x minus x2 هنا ما تاخذ x minus x0. Okay, and in the denominator same expression just plug in x0 instead of k. هذه هي. Okay, so لما تشوفها هنا خاف it's scary but it's not complicated, it's easy to remember. Good. So الحين as we are used قلنا in practice we'll replace f by this polynomial, but it's just an approximation because the original function is not a polynomial. So what is the quality of this approximation? Can we have a bound on the error when replacing the function f by the function p? We want to be confident. We want to be sure that replacing f by p ما يعطينا high error، ما يعطينا data which have no sense. Okay, we need data which are close to the exact or correct data. Okay, so we have this error formula. What does it say? It says that the function f is equal to p, which is the interpolating polynomial, plus, and this is the error, the remainder term. Let's study this error. What do we have in this error? We have the derivative of order n plus 1. I repeat, n plus 1 is the number of points. I repeat that the interpolating polynomial is degree n. So the remainder will be a polynomial of degree n plus 1. It's here we take the product all of x minus xk. So here we take all product. كله multiplied by the derivative of order n plus 1 of f at a given function of x unknown divided by n plus 1 factorial. It's quite similar to Taylor, looks like error for Taylor polynomials. There are some similarities. So for Taylor's, it's Tn of x plus, what is the remainder? It's also f derivative n plus 1 of some unknown function, n plus 1 factorial. But in Taylor, we have only one point, x0. So we have x minus x0 to the power n plus 1. كلهم هذم x minus x0, x minus x0, x minus x0 في Taylor. Here we have the product of x minus xk with n plus 1 different points xk. Okay, so this is the difference between the two. I repeat, Taylor polynomial, we focus close to 1 point x0. Here we have n plus 1 points. So we replace the product of x minus x0 n plus 1 time. Here replace it by the product of x minus all xk. Okay, so looks like the same idea. This is the error. This is the reminder for Lagrange polynomial. Here, psi k is unknown. I don't know it. And I don't want to know it. Okay, and I can't know it. Okay, so, but this is, okay, we can manage this. We'll not find the exact error, but we'll try to get bounds on the error. Okay, we try to get bounds on this quantity by some constant to have an idea of the error. Okay, a bound on the error. Okay, we'll always do that in such numerical methods. Good, let's see an example. Use these numbers to find the second Lagrange interpolating polynomial for the function f of x equal 1 over x. So how many points are we given in this example?
3 points.
We are given 3 points. So what is the degree of the polynomial in this case?
3,
No,
4.
no. نرجع هنا.
Is it n, right?
How many points here?
2 points.
2 points. What is the degree of the interpolation polynomial? What
1.
is the degree 1? إذا إيش قلنا هنا؟ قلنا n plus 1 points, n plus 1, we get a polynomial of degree n.
So minus 1, it will be 2, right?
So هذا is n plus 1, the number of points n plus 1 from 0 to 2. What
Yes.
is the degree of the polynomial?
2.
The polynomial of degree 2 here. So what is the formula for this polynomial? It's f naught L naught of x plus f1 L1 of x plus L2 f2 L2 of x. هل نعرف ال f0? Who knows f0?
Undefined, right?
No.
Is it 1 over x?
This is the function fx, 1 over x. I want f0. What is f0?
No, 1 over 2.
f0 هي f of x0. So here it's x0 is 2, so 1 over 2. What is
So
f1?
1 over 2.75.
1 over 275. What is the value of f2?
1 over 4.
1 over 4. Okay, these are the outputs. Y0, y1, y2, or f0, f1, f2, or f of x0, f of x1, f of x2. So this must be given. All this must be given and known. We must know the input and the output for all these 3 points here. اللي لازم احنا
Yes.
نشتغل عليه ونحسبوه هو ال هما Lagrange polynomials L0. كيف نجيب L0 of x? What is the formula?
It will be x minus x1.
Good.
Then x minus x.
Times, مش then, times x minus x2 over x0 minus x1 times x0 minus x2. So it's x minus 275 times x minus 4 over 2 minus 275 times 2 minus 4. And we calculate this. You distribute and you simplify. What is L1?
It will be x minus x0 multiply
Good.
x minus x2.
Good. So now you understand. Divided by
x1 minus x0, x1 minus x2.
Okay. So you understood this formula. And you replace. X0 come
2,
x2
4,
x1
275,
x0
2,
x1 275 L2
x minus x0 multiply x minus x1 over x2 minus the same.
And you replace x minus x0 here 2 or x1 here 275 minus 4 minus 2 4 minus 275. So عندنا ال FI وال F case عندنا ال L case يبقى فقط انك تحسب تعوض هنا ال L0 ال L1 L2 and you simplify and you get your interpolation polynomial. This time let's see what is the final answer. So here this is the formula. Then هذه x1 هذه x2 هذه x0 minus x1 x0 minus x2. من هنا هذه x minus x0 هذه x minus x1 هذه x2 minus x0 هذه x2 minus x1 since we are calculating L2. You calculate and you obtain this and then you have the formula. You have f of x0 حسبناهم f of x1 f of x2. You plug here تعطيك half في هذه plus 4 over 11 في هذه plus 1 over 4 في هذه you get إذا منين جات هنا ال 1 over 3 هي ال 1 over 2 times 2 over 3 تعطيك 1 over 3. So you simplify and this is your Lagrange interpolation polynomial and you can check that P of 2 is half, that P of 4 is 1 over 4. So this is how to determine the Lagrange interpolation polynomial. السؤال الثاني يحب the error. You want to be confident, so we'll not use 1 over x in our calculation, but we'll use this polynomial of degree 2. What's if we replace f by p, what is the maximum error we are doing? this is given, but this is not easy. So what is the expression of the error of the remainder term? قلنا it's the derivative of order n plus 1 at some given function of x over n plus 1 factorial times the product x minus x0, x minus x1, x minus x2 in this case. Okay, so to find the error, we need to do a lot of things. We need to calculate the derivative of order n plus 1 of f. We need to determine the maximum value of this derivative on our interval. And we need to determine the maximum value of this product, of the absolute value of this product on the interval AB. So this is not easy, but if we are asked to do it, we have to do it. So n plus 1 هنا بكم? I recall we have 3 points. 2, 1 over 2, 275, 1 over 275, 4, 1 over 4. We have 3 points. On the 3 points, هذم n plus 1. Then here we need to calculate the third derivative. So I'll do it once. So since f of x here 1 over x, or x to the power negative 1, what is the first derivative? So what is the derivative of x to the power n?
nx.
N, x, n minus 1. What is the derivative of the power function? F to the power n? In a composition chain rule. N, f prime times f to the power n minus 1. Okay, but here, alhamdulillah, it's easier since it's x only. It's not a function of x. إذا starting n here negative 1, x minus 1 minus 1, so minus x negative 2. The second derivative, that in minus, حين صار n minus 2. So minus 2 for x minus 2 minus 1, دايما n minus 1. So that you need 2x minus 3. And the third derivative will be 2 constant times n minus 3 times x minus 3 minus 1. So minus 6x minus 4. So this is the third derivative. Now we need to determine the maximum of this derivative. On which interval? شو راح يكونوا A, B هنا؟ هو the first point 2
4.
and the last point 4. We are working on this interval x0, xn. So what is the maximum value
half.
of this function? So the maximum value on 2, 4 of without minus, so 6 over x4. So we can see that this is a decreasing function. So its fourth derivative is negative. So it's the max 6. So the maximum is reached at the left end point. So 2 to the 4. So 6 over 16, 3 over 8. So this is the first value. We are not done yet because we need also to determine the maximum of this product. إذن هنا we need the maximum for x between 2 and 4 again, x0, xn of here x minus 2, x minus 275, x minus 4. So this is a polynomial of degree 3. لازم نحسب this polynomial. So here we calculate different derivative of f. We need the maximum of this quantity. So this is the polynomial x minus x0, x minus x1, x minus x2. حسبوا هنا. لازم you calculate this polynomial. You write it in standard form. So we have to determine the derivative. اللي هي 3x squared minus 35 over 2x plus 49 over 2. And then we have to find critical points. How to find the maximum or a minimum of a function by trying to find the critical points. What does it mean, critical points? Means when the derivative is 0. So you have calculator, you can use here your calculators to find the critical points of this function, since it's a polynomial of degree 2, equation of degree 2. So we can solve it using a calculator. So you can try it. So Tatina, these are the critical points. X equals 7 over 3. So here we need two solutions. X equals 7 over 3 or x is 7 over 2. So these are the critical points. And these are the image of the critical points. And you have also to calculate the image of the endpoints. So this is what we did. And here, this is the error. The error is 3 times 10 minus 2. So this is the idea. So we have here two significant digits. So here the quality of the approximation is around the error if the order of 10 minus 2. Of course, since we took only 3 points. So of course, to improve the quality, we need more points, higher the polynomial degree.